Hello everyone, welcome to my video on the quotient rule. So we saw product rule when you have a multiplication of functions. How do we take its derivative? Now we're looking at a quotient, the division of two functions. So in order to apply the quotient rule, first things first, we need f of x and g of x to be differentiable, so their derivatives have to exist. If you're given a function k of x, which is expressed as f of x in the numerator and g of x in the denominator, where the denominator cannot be equal to 0, then we express the derivative k prime of x as f prime of x times g of x minus g prime of x times f of x, all that divided by g of x squared. So this formula is similar to the product rule in the sense that you're multiplying one term, like the numerator is essentially the same, except that the addition turns into a subtraction, and then you just have the added step where you have to divide by the denominator squared. Okay. An easier notation to remember is if you have f over g, all that prime, you could rewrite it as f prime times g minus g prime times f over g squared. Okay. So one thing that's really important to keep in mind here, when you're doing product rule, the multiplication, it doesn't matter which one you derive first. Quotient rule, it does matter. Be careful, because we have not an addition, but we have a subtraction sign. So you have to follow the rule as is. So what I'm saying is that when you're doing quotient rule, a common mistake that students were making was that they weren't taking the derivative of the numerator first. This statement here, taking f prime, you have to take the derivative of the numerator first and then multiply it by g, subtracted by the derivative of the denominator times the numerator, okay, and then all that divided by the denominator squared. So make sure you keep this order. This is super important. Power rule, it doesn't matter. For quotient rule, the order matters, okay? So be careful for that. This is the easier notation. Keep this in mind. This is the way I would write it down, let's say, on a test. Just to remind myself, this looks a bit more complicated. This notation looks a bit easier to remember. So write that down. I'm going to erase it. And let's look at the proof. So the proof, we're going to start off by writing k prime of x. Again, we always write our limit definition, limit as h tends to 0 of k of x plus h minus k of x, all that divided by h. So the limit as h tends to 0, k of x plus h, k of x is f of x over g of x, so this is just f of x plus h over g of x plus h, minus, and k of x is just f of x over g of x, all that over h. Okay. So we can think of h as h over 1, because we have a fraction divided by a fraction. That should remind us on what to do here. And the first thing, looking at the numerator, is I'm subtracting fractions. Whenever you're subtracting fractions, think of numbers. How do you subtract these terms? 1 over 2 minus 3 over 5. Our goal would be to find the common denominator. Same thing here. So let's go ahead and find a common denominator. So we could rewrite this as the limit as h tends to 0 of g of x times f of x plus h minus f of x times g of x plus h, all this over g of x plus h times g of x. Okay. And instead of dividing by h over 1, since we're dividing fractions, I'm just going to multiply by the reciprocal. Fraction divided by a fraction means you could rewrite it as the fraction, the first fraction you keep as is, which we found the common denominator, but the second fraction we're just going to multiply and flip it. So this is the same as multiplying by 1 over h. Okay, so instead of h over 1, you're multiplying by the reciprocal. So the h is here on the bottom. Now let's keep going. We could rewrite this as limit as h goes to 0. And again, this is the part of the proof where we do something, we're not sure why we do it, it ends up working. So we're going to rewrite this as g of x times f of x plus h. And we're going to subtract g of x times f of x. But at the same time, we're going to add that guy back in, plus g of x times f of x. So again, this is adding and subtracting nothing. So this is okay. We're allowed to do this. Minus f of x times g of x plus h. Right. So everything in black is the same. The piece that's in red is the same number, opposite sign, so they would cancel. So it's a fancy way of adding 0. We're allowed to do this. There's no issues here. We have the h over here, then we have g of x plus h times g of x. Okay. So if we look at the first term here, what we could do is factor out a g of x. So this is equal to the limit as h tends to 0. Looking at the first term, we factor out a g of x. Yeah. And we're left with f of x plus h minus f of x. And then I'm going to divide it by the whole bottom here. Okay. And on the right side here, we'll take the limit, so plus limit as h tends to 0. And this term, there's an f of x that they have in common, so we're going to factor out an f of x. And we're left with g of x minus g of x plus h over the denominator. H times g x plus h times g of x. Okay. So it's a bit complicated here, but so far we're at this stage here. On the left hand side, if we focus here, notice that the g of x is cancelled here. Okay, and I'm gonna have to erase the top just to give myself a bit of room. So let's continue up here. And what we notice here is if you take the limit on this side, we have the limit as h tends to 0 of f of x plus h minus f of x over h. This here, with this h on the bottom, is the limit definition of a derivative for f. So what we have here is f prime of x over g of x. Because we're taking the limit as h goes to 0, so the h inside the g is gone. It's replaced with 0, so we're just left with g of x. We get this over here. On this side, there's a bit more work to do. What do we have? We have an f of x on the top, and we have to be careful here. If we look over here, this piece here, maybe let me circle it in red, just to make it a bit more clear. We have g of x minus g of x plus h divided by h. And we're taking the limit as h goes to 0. So this f of x, let's rewrite it. We have f of x. But what I'm going to do, instead of a plus, what I'm going to do is I'm going to factor out a minus, because notice this is very similar to our definition of a derivative for g, but it's the wrong form. We're supposed to have f of x plus h minus f of x. Here it's the opposite. We have g of x minus g of x plus h. We want the opposite. We want g of x plus h minus g of x. To rectify that, what you could do is factor out from the top a negative. Okay, so if we factor out a minus 1, what we get is we put a minus here, and now this becomes a limit definition. So our plus turned into a minus, and the signs here switched. So this becomes a minus, this becomes a plus. And now we have it. We have g of x plus h. If I put this on the other side, it's g of x plus h minus g of x over h. And this is the limit definition of a derivative for g of x. So we get g prime with the limit. And again, if we take the limit on the denominator, the h goes to 0. So we have g of x times g of x, giving us over g of x squared. Okay. We're almost there. So all we have to do now is we have a fraction with a subtraction in the middle. So we got the minus sign, that's good. We just have to find a common denominator. So here we have to multiply the top and the bottom by g of x. Multiplying the top and the bottom by g of x, we get g of x times f prime of x minus f of x times g prime of x. And since we multiplied the top and the bottom by g of x, we have the whole thing over g of x squared. All that squared. And we're done. This is what we wanted to show. Erase this. Let me put the equal sign here. F prime of x times g of x, f prime of x times g of x minus g prime of x times f. Yeah, f of x times g prime. The fact that the multiplication is off, it doesn't matter. Again, 2 times 3 is the same as 3 times 2. And then over g of x squared. We got it. So this is done. So this is the proof for the quotient rule. Let's look at some applications and do some practice problems. Okay, so in this example here, we have to find k prime of x, given that k of x is equal to x cubed divided by 3 to the x. Okay, so pause the video, try this on your own. If you get the answer as 3x squared over 3 to the x times ln of 3, this is incorrect. Okay. So be very careful. Remember, you have a division of functions. We have to apply the quotient rule. You do not take the derivative of each term individually. This is wrong. You have to apply this formula here. So let's go ahead and do that. So keep in mind the numerator is your f and the denominator is your g. Okay, so for the solution, k prime of x is equal to the derivative of the top. So I'm going to do it this way. X cubed prime times your g, so the bottom we leave. So derivative of the top times the bottom minus the derivative of the bottom times the top. So the derivative of the bottom is 3x prime. I'm going to put prime for now, times the top, which we leave, x cubed, divided by the bottom squared. So 3 to the x, all this squared. Okay, and now we could derive each term, giving us x cubed, the derivative of x cubed is 3x squared times 3 to the x minus the derivative of 3 to the x is 3 to the x times ln of 3. We saw this in our videos on exponentials. And then the x cubed we leave. And then the bottom is over 3 to the x, all that squared. Okay, so now we simplify. So again, if it asks to find the derivative, this is sufficient. Your answer here is correct. But if it says also to simplify, we're going to go one step further and factor. The most we could take out here is a 3 to the x. This guy's a 3 to the x. We have an x squared here, an x cubed here, so we have to take essentially the lowest exponent. So we could take out an x squared, and that's it. So if we take out 3 to the x times x squared, we're left with just 3 here, minus the 3 to the x comes out, the x squared comes out, so we're left with 1x. We're left with ln of 3 times x. All this over 3 to the x, all that squared. So in the numerator we have a 3 to the x, on the denominator we have 2 of them, so we can cancel one of them out, leaving us with x squared, 3 minus ln of 3x, all this over 3 to the x. And this is the final answer. Okay, so in this example here now we have k of x is equal to x to the 2/5 minus the cube root of x, all that divided by 5 log of x. So pause the video, try to attempt this on your own, see if you get the answer. Let's go ahead and solve. So k prime of x, we start off by taking the derivative of the top. So what I would do is probably set myself up. So I would rewrite this as x to the 2/5 minus x to the 1/3, all that divided by 5 log. Maybe log base 10 of x just to help myself out. And now I'm ready to go. So the derivative of the top is 2/5 x to the negative 3/5. So we subtract the exponent by 1. We drop the exponent to 2 over 5, and then we subtract it by 1, giving us negative 3/5 minus 1/3 x to the negative 2/3. This is my f prime. So all I did was the first piece. Now we have our g. So times g, our g is the denominator, we just multiply, so 5 times log base 10 of x. Okay, I'm running out of room. Minus, this should all be on one line, but I don't have room, so I'm just going to continue down here. Minus g prime now, so we have to take the derivative at the bottom. So 5 stays, it's a constant, log base 10 of x. You have to remember the derivative of log is 1 over x times ln of the base. Okay. So the base of the log is 10, so it's going to be 1 over x times ln of 10. And then multiplied by the numerator, which we leave, x to the 2/5 minus x to the 1/3. All this divided by, so again, this should all be on one line. It's not a fraction. That whole line divided by the denominator squared. So 5, or if you want 25, log of x, all this squared. So this we could simplify it a bit. So let me write it over here. In terms of finding the derivative here is correct. Let's go ahead and simplify, giving us 2 over 5x to the 3/5 minus 1 over, so recall we don't want any negative exponents, 3x to the 2/3, we drop them down. So those guys were dropped here. This 5 and this 5 here, we could factor them out. So times log base 10. So I factored out this 5, I'm going to factor out this 5, it's in the front. So I'm just keeping that in the back of my mind. Minus 1 over x log ln of 10 times, here there's nothing to do, x to the 2/5 minus x to the 1/3. Okay, so again here there was a 5 as well, but I factored it out, and the 2 5s that factored out cancel with the 25, which 25 you can think of as 5 squared. So if we have a 5 on top and we have 2 5s on the bottom, we're left with 1 5 on the bottom, giving us 5 log of x squared. And this is the final answer. Good. Let's take a look at a final example. Okay, so I strongly encourage you to practice this example on your own. We have to find k prime of x. They give us the function k of x is equal to the square root of pi to the 5 plus 1, all that divided by ln of 14 to the e plus 2022. Okay, so give it a shot, pause the video, and see if you get the same answer as me. So if you got the answer is equal to 0, good job, that's the correct answer. Okay. This is a trick, don't fall for these tricks. Notice that there's no x's involved in the function, this is just some number, it's a constant, and we all know that the derivative of a constant is 0.